All right, here's a video for note 0-5, Pythagorean Theorem and distance formula. So just a little reminder about Pythagorean Theorem. Pythagorean Theorem basically states that if we square one side of a right triangle and add it to the square of the second side of the right triangle, it's going to equal the square of the third side, particularly the hypotenuse. So in this case, we see that 3 squared, so 9. So there's 9 total boxes here. There's 16 total boxes here is going to equal 25. So 3 squared plus 4 squared equals 5 squared, 9 plus 16 equals 25. So to kind of formalize this a little bit, a squared plus b squared equals c squared. Another way we can kind of generally say it is that a and b are called legs, and these are the parts of the triangle that form the right angle, and c is called the hypotenuse. So another way we can do this is leg squared plus leg squared is equal to hypotenuse squared. Doesn't matter how you label a or b, but the hypotenuse is always across from the right angle. All right, so just a couple examples here. So what I always like to do, just to make sure I don't make a mistake, I always like to highlight my hypotenuse to make sure that I put the correct side by itself, because remember, it's leg squared plus leg squared is equal to hypotenuse squared. So this is a leg, this is a leg, this is the hypotenuse. So we're going to solve for x here. So it's going to be x squared plus 5 squared is equal to 11 squared. So the hypotenuse is always by itself. So then I'm left with x squared plus 25. 11 squared is 121. Then for this one, we're going to have to subtract 25 from both sides to get x by itself. So then we have x squared equals, let me pull up a calculator. So 121 minus 25, that's 96. And then the last step with Pythagorean theorem, if we want to get x by itself, we take the square root of both sides. So just like before, we're going to write two answers. Well, first we're going to put that in our calculator and see what we get. Square root of 96. So we get a decimal. So anytime you get a decimal like this, I want two answers. I want your exact answer and your approximate. So for right now, we're just going to keep this as my exact answer. There is a way that we can simplify this square root, but we're going to get into that in a later unit. And then we want our approximate answer. So our approximate answer is what we get in our calculator. So we're going to round to two numbers after the decimal, so 9.79. But then we're going to look at one number after. Since that's greater than 5, we're going to round up to 80, 9.80. All right, so let's look at the second one. Again, I'm going to highlight my hypotenuse across from my right angle. This is my hypotenuse. So I have my two legs and my hypotenuse. So it's going to be 11.5 squared plus 4.6 squared is equal to x squared. So I'm going to put this in my calculator. So 11.5 squared plus 4.6 squared equals 153.41. And then just like before, we're going to take the square root of both sides to get x by itself. So square root 153.41. So we get a decimal, so I'm going to write two answers. My exact answer, I'm just going to leave it in the square root. And then my approximate answer, I'm going to take my calculator answer and round to two numbers after the decimal. So again, here we go, 12.38. But since 5, you round up when it's 5 or more, so that's going to be 12.39. So my exact answer as well as my approximate. Your exact answer is more precise, but your approximate answer gives you an idea of how long it is. One last thing you can check just to make sure you have the right answer. Remember that your hypotenuse is always the longest side, so when you check, you should make sure that your hypotenuse is longer than both of your legs. Okay, so now what happens if we're given a graph? Well, if we're given a graph, what we could do is we can actually turn this into a right triangle. Right? I can take a highlighter, and what I can do is I can draw this bottom leg here. So I can make that leg, and then I can extend B down to connect there, and I'm left with my right angle right here. So now I have a right triangle. This is a leg, and I have my hypotenuse. So let me do it in yellow. Okay. Now we just need to count how many boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9, and then I have 1, 2, 3. And now I can do Pythagorean theorem. So 9 squared plus 3 squared is equal to c squared. 9 squared is 81. 3 squared is 9. And then we're going to add these together. 81 plus 9 is 90. And just like before, square root both sides. So we're going to put this in our calculator. Square root of 90. So again, we get a decimal. That means we're going to have two answers. My exact answer is c equals the square root of 90. And then my approximate answer is going to be, so we have 9.48, and then we have 6, so that's going to be 9.49. Okay, so now what happens if we're given the coordinates only and we're asked to find the distance between 2 points? Well, one thing we could do is we can graph it and see. However, if you're not given a graph, there's a few other ways that we can tell. So let's go back to this example and see. The coordinates of B was 3, 5, and the coordinates of A were 0, -4. So then we have to ask ourselves, well, how did we find 3 and 9? We counted the boxes, right? So when looking at this leg right here, we can look at the y values since y goes up and down. And the way that we can get 9 from getting the y values is really by doing 5 minus -4. Right? 5 minus -4. We can see how many steps do we have between 5 and -4. We're at 5, 4, 3, 2, 1, 0. -1, -2, -3, -4. So that's 9 total boxes. Or we can do 5 minus -4. All right, so using the same logic here, I can find the distance between these 2 points by subtracting them. Well, -3 minus 8 is going to give me -11, but we know distance is always positive, so that's going to end up being a distance of 11. Or you can think on a number line, the distance between -3 and 8, well, that's -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. And if we count these, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's where the 11 comes from. And then using that same logic, we can look at the x values and do the same thing. Well, looking at our x values here, that's 3 and 0. Again, we can subtract them. 3 minus 0 is 3. So I did -3 minus 8. You can do the same thing here. 18 minus 7. And 18 minus 7 is 11. Okay, or if you want to just count the distance between 18 and 7, you could do that as well on a number line. Well, then what did we do next? Well, what we did next was we then did Pythagorean theorem. We squared this and squared this. All right, so I'm going to square this, and I'm going to square this. And we add them together doing Pythagorean theorem. And then the very last thing I did was take the square root of both sides, which I can really just say, well, I'm just going to take the square root of this whole thing. And that's essentially what we did to find the distance between the 2 points. So really what we're doing here, let's just finish this problem. 11 squared is 121. -11 squared is 121. So then we have square root of 242. That's the distance between the 2 points. So I'm just going to write it as d equals And now let's put that in our calculator. We get a decimal, so I'm going to write two answers. Exact answer is square root of 242. And then my approximate answer, we're going to say 15.56. 15.56. Okay, so generally what we did, we basically just came up with a new theorem here, and it's called distance formula. So if we call this point x1, and we call this point y1, and we call this point x2, y2, we can find the distance between the 2 points by doing this formula. We can find the distance between the x values, so x, well, really doesn't matter the order, so I'll call this x2. So I'm going to do 18, or x2 minus x1, square that, plus, and then the distance between the y values. So we're going to subtract them, y2 minus y1. So this right here is what we can use to find the distance between 2 points. Okay, another way we can do that without having to do distance formula is a method that I like to call stack and count, which I'll show for this example. And it's basically doing the same exact thing. So I'm going to stack my points. So 7, 4, there's the first point, and -2, 9. And I'm going to figure out the distance between these 2 points. So thinking of a number line, if I'm at 7 and I need to get to -2, I'm going to have to take 9 steps. I'm going to keep it positive because distance is positive, right? I need to go from 7 to 0, that's 7. And from 0 to -2, that would make 2 more. So that's 9. And then to go from 4 to 9, it's 5. Okay, the other way you can think of it, in this case, you could do 7 minus 9 would get me to -2. Think of it that way. And 4 plus 5 would get me to 9. Okay, but again, I'm keeping this positive because distance is positive. Then from here, this is A and this is B, and now we're just going to use Pythagorean theorem. So I'm just going to keep it positive because distance is positive. 9 squared plus 5 squared is equal to c squared. So 81 plus 25 is equal to c squared. So c squared, 81 plus 25 is 106. And then we're going to take the square root of both sides. So again, we have a decimal, so I'm going to leave my two answers. C is equal to the square root of 106. That's my exact answer. And then my approximate is going to be 10.30. So that's one way you can do it instead of having to use distance formula. All right, now I'm just going to go over a couple of the homework problems. So starting with number 2, when you're given a graph, you can just turn this into a right triangle. So I'm just going to extend this down here and extend this over. And I'm going to count the side length. So this bottom part is 3. This is 1, 2, 3, 4, 5, 6. And then we're just going to use Pythagorean theorem. So 6 squared plus 3 squared is equal to c squared. So that's 36 plus 9 is equal to c squared. So 36 plus 9, I believe, is 45. And then we're going to square root both sides. All right, so c is equal to the square root of 45. That's my exact answer. And then my approximate answer is going to be, so 6.70, 8's next number, so 6.71. All right, next one here. Again, I'm going to use Pythagorean theorem. So I'm going to highlight my hypotenuse, which is this one. Okay, and then these are my legs. So x squared plus 6.9 squared is equal to 11 squared. So 6.9 squared is 47.61. 11 squared is 121, and I'm going to subtract. $73.39. And then square root both sides. So decimal, so one answer is going to be just the square root of 73.39. And then my approximate answer going to be 8.57. All right, this one says draw a diagram. So it says the bottom of a ladder must be placed 3 feet from the wall. So here's my wall, and then here's my ladder. So it says the bottom must be 3 feet from the wall, and we know that our ladder is 12 feet tall, or 12 feet long. We want to know how high above the ground does the ladder touch the wall. So we're solving for this side. So here's my right angle. Now we're just going to do Pythagorean theorem. This is my hypotenuse. So it's going to be x squared plus 3 squared is equal to 12 squared. So x squared plus 9 is equal to 144. This one we're going to subtract. $135. And then square root both sides. So again, I have a decimal, so exact is square root of 135. And then my approximate, we're going to round. So two numbers after, that's 6.1, and then we have 8 next, so we're going to round up to 6.2. So 11.62. All right, last example here. Find the distance between each pair of points using distance formula or Pythagorean theorem. So I'm just going to show using Pythagorean theorem basically stack and count. So I'm going to take my points and I'm going to stack them. I'm going to count the distance between the two. Or we can think -8 plus what would get me 3? Well, that's going to be 11. And then -5 plus what would give me -1? That's going to be 4. So the distance between -8 and 3 is 11. The distance between -5 and -1 is 4. So then this is our leg. This is our other leg. 11 squared plus 4 squared is equal to c squared. So 121 plus 16, 37. And then square root both sides. We get 11 point. So this one we're going to leave as 70 because the next number is 4. Oops, that's my approximate answer. And then my exact answer is square root of 137.